Good evening, Mom.
Yeah, good evening to Gagan Sai. Yeah, today is the 7th class mathematics. Chapter number is the first chapter, integers. Today we learn the new topic, 1.2.3 in Telangana State Book, properties of integers under subtraction. Page number is the 20-22. Today we learn it only. Other book after later only learn it only. So first of all, Telangana book today we learn it only. Yeah, first one is the properties of integers and subtraction. Do you know the previous class Gagan Sai neatly are you understood? Exercise are 1.5 all problems and solutions, are you understood?
Yes.
Okay na? Properties of integers under addition and multiplication. Your previous class is over. So are you understood of that two properties Gagan Sai? Properties of integers under addition and multiplication. Are you okay? We understood? Yeah, today we learn the new topic is the properties of integers under subtraction only. Yeah, first listen better neatly. Yeah, first one is the closure under subtraction property. Yeah, first one is the subtracting one integer from an other integer. We get the integer, we get always integer.
Yes.
Check it only. If it's some examples today we learn it. Through examples today we learn it only. Some examples. Let us consider the some examples. These are all the some examples. Let us consider. Consider some examples. Is it subtracting of any two integers? Is it always integer? Either it is or wrong. You say check it only. First examples is that 8 minus 6 is 2 only. 7 minus 10. For examples of 7 minus 10 is the minus 3 only. Next is the 2 minus 3 is the minus 1. Next minus 2 minus 3 is the minus 5 only. Next minus 2 minus into minus is the plus.
Yes.
So that's why it's the 3 only. Next 0 minus 4 is the minus 4.
Minus 4.
So these are all is that always integers Gagan Sai neatly?
Yes.
We get the answer is that integers or
No.
is it correct?
Minus.
Yeah. And we say that integers follows the closure property for subtraction. Yes.
You okay?
Yeah, these are all is the integers only. So integers all under closure property for subtraction only. Okay now, in general, any integers A and B. Okay now, A and B, comma A minus B is also an integer. Is it correct Gagan Sai?
Yes.
Yes. Integer. Yeah, some examples also. Textbook is also there. Gagan 9 minus 7, 2, and here it is also 3 and minus 1, minus 5, and here minus 2 into or plus 3 only or minus 4. Here some alag examples only. Are these are the closure property under addition of that. And A minus B is also integers only. And next one is the commutative under subtraction only. Commutative under subtraction is let us take some examples only. Let us consider some examples of integers. So for examples of these are some examples
Of integers.
yeah, let us consider some examples. Yeah, some examples. So first of all, let us consider the integers. For examples of 8 and minus 2. Another one is this is the first problem, and the second one is the 7 and minus 5 only. Okay now? Yeah. Is it satisfy that the commutative under subtraction only? Subtraction is it commutative?
Yes.
For integers, check it only. Yeah, first one is the these are all is the two examples only. Our first example is the 8 minus of minus 2 only. Okay na?
Minus minus plus.
Yeah, minus into minus is the plus. So
10.
that's why is the 10 only. And another one is minus 2 minus of 8. So that's why
Minus,
the minus 2
plus.
minus 8.
10.
So that's why the minus 10 only. Both are equal or not equal? Both are not equal.
Yes.
So that's why is not satisfy this commutative under subtraction only. Is not a commutative under subtraction only. So that's why you can about 8 minus minus 2 equal to minus 2 minus of 8 is not equal. Both are not equal. 10 here it is the 10, here it is also minus 10 only. So that's why both are not equal only. Yeah, another example here solution. Yeah, first one is the 7 and minus 5 only. So that's why the 7
and
yeah,
minus 7 and
minus 5. Yeah,
7 and minus
5. So that's why the what's one is the little better neatly 7 plus minus into minus is the plus. So that's why is the 12 only. Yeah, another one is the minus 5 minus 7 only. So that's why is the minus is the minus only. So that's why is the minus 5
12
7 is the 12 only. So that's why is the both are equal.
Yes.
Yeah, no, not equal only. This is the plus 12 and this is the minus 12. So that's why the first one is the 7 minus 5 is not equal to minus 5 minus 7. Both are not equal only. But here it is the 12 not equal to minus 12 only. So that's why you understood. I can say here it is also examples of your textbook is also some examples there. So subtractions is not a commutative.
Yeah.
No, not commutative.
Okay.
And thus subtraction
Is not competitive.
subtraction
Is not competitive.
subtractions is not
Competitive.
commutative for integers.
For integers. Okay.
For integers. Okay, you can say.
Okay.
Okay. Yeah, the subtractions is not a commutative for integers only. Yeah, next property is that some let us try to our other examples is also for examples of 2 comma minus 6 alage examples at home you can practice there. Yeah,
Yes.
try this at least any two problems, same models of any two problems you can solve it only. For example, 2 and minus 6 and 2 comma minus 4, then minus 4 comma 5 and 5 alag examples you can same you can practice only. And another one is that another topic is the properties 1.2.4 is the properties of integers and under division only. Are you understood the answer neatly?
Okay.
Yeah, closure under subtraction for integers is okay, but you are commutative not under subtraction only. Yeah, another property is the under division only. So that's why the first one is the closure property. What's the closure property? Yeah, first one is the table form. Over here it is that one examples are through. You learn it the following the table. And today we will learn it on some examples. If it's take the some examples of statements, today we will learn it only. If it's either as integers or not closed or closed under
division.
It's a check this some examples, alag examples only. If you take the alag examples of statements only. The first statement is the minus 6 divided by minus 2 only. Minus 6 is divided by minus 2. Minus into minus is the cancel. So that's why the 2, 3 only. Okay, you can say?
Yes.
Yeah, inference. Inference means the result is an integer. 3 is the integer.
No.
Integer.
Three is the integer.
Yeah, so that's why is a result is an integer. Okay, is an integer.
Okay.
Yeah, next one is the other one same examples of minus 2 is divided by minus 6 only. So that's why the minus 2 by minus 6 only. So minus is the minus cancel. So that's why the 1 1 ja 2 1 ja 1 and 2 3 ja 6 only. So that's why it's the 1 by 3. 1 by 3 is an integer?
No.
No, it is not integer only. So that's why the result is not integer. Not integer. Okay? Yeah, other further other examples you can say neatly. Let us take that other examples. For examples of 18. Minus divided by 18 by 2 only. Okay na? 18 by 2 means is the 9 only.
Yes.
So it is a result is an integer?
No.
Yes, 9 is the
Yes,
integer. It is an integer. Yeah, next one is the minus 2. 2 is divided by minus 18. So that's why the 2 by minus 18. So that's why the 2 1 ja 1, 2 9 ja 18 only. So that's why the 1 by 9. 1 by 9
No,
is
not
an
integer.
integer.
Not
so that's why
integer.
not integer.
Okay, I understood that.
Not integer. Yeah, other examples is also if it's words or integers are not closed under division also. Yeah, other examples for examples of 12. Okay na? 12 plus 12 is divided by the 3 only. So that's why the result words are is 4 only. So that's why the 4 minus 4 only. All or both are the positive only. Positive integers is both are divisible by the positive integers. We will get the answer is the positive only.
Okay.
Positive integers. So that's why it is an integer. 4 is the it is an integer. Is it integer?
4 is
Yeah,
it is an integer.
Integer. Yeah. Next one is the what one is the 3. 3 is divisible by 12 only. So that's why the 3 by 12.
No,
So
it is not an
3 1
integer.
3 4. So that's why it is not a
Integer.
integer. Not integer. Yeah. Next other examples. For examples of other examples is 25 by divisible by minus 5 only. So that's why the what's the answer is the minus 5 is the answer. 5 minus 5 is that is an integer.
No.
Yeah, it is an integer only. It is an integer. Okay, now next is the minus 5 is divisible by 25. So that's why is the minus 5 by 25. So that's why the 5 1 5 5 5. So 1 by minus 1 by 5.
No, it is not an integer.
Integer. Okay, the other side. Yeah, it is not an integer. Yeah, words are understood the other side. Words are observing from the above table. Words are you understood from the above table. You can work closure property as under not closure. Closed under division only.
Yes.
Okay na? Not satisfied. So that's why you can alag examples if let us try to after later only. Okay na? Next one is the second one only. Commutative property. Commutative property. What's the commutative property? How do you know that the division is not a commutative for whole numbers only? Yeah, let us check for that integers also. Yeah, for examples of here it is that some examples let us consider the examples only. For examples of here it is that minus 8 and divisible by the minus 4 only. Minus 8 is divisible by minus 4 only. Equal to minus 4 is divisible by minus 8. Both are equal or not. If you check it commutative property, if you check that only. Some examples here, 3 examples are there in this property. Through examples today we will learn it only. Yeah, first examples one is the minus 8. This is the one only. Minus 8 divisible by minus 4. So here it is the words minus is cancel and 4 2 ja divisible. What's the quotient is the positive quotient, that is the 2 only. And next one is the minus 4 is divisible by minus 8. So that's why the minus cancel Yeah, 1 4 by 8 only. So that's why it's a 1 by 2 only. Okay, both are the equal? Yeah, not equal only. So that's why you can is a minus 8 is divisible by minus 4 is not equal to minus 4 is divisible by minus 8 only. Are you okay, Gagan? So both are the equal or not?
Equal.
Or not only.
Not
But here
equal,
2
not
here it is
equal.
the another one is the 1 by 2 only. So that's why they are not both are not equal only. So that's why you can other examples are another one is the second example. So what's the is the minus 12 is divisible by 3 equal to 3 is divisible by minus 12 only. Is it both are that equal or not equal? If you check it only. Solve it. First of all solve the second problem. Yeah, first one is the 12 is divisible. Yeah, next one is the 2 minus 12 divisible by 3 equal to 3 is divisible by minus 12. LHS and RHS. So that's why you can is the 3 minus 4. 12 minus 12 is divisible by 3 is the minus 4 only. Equal to 3 is divisible by the minus 4. 3 1 is 1 and 3 4 is 12 only. So that's why it's a minus 1 by 4. Both are equal or not equal? Not equal only. Minus 4 here it is the minus 1 by 4. So that's why both are not equal only. Is it correct?
No.
Minus 12 3 is not equal to 3 is divisible by minus 12. Both are not equal. So it's not a commutative property under division. Okay na?
Yes.
Yeah, next one is that also other examples is also the third examples. Yeah, minus 30 is divisible by 6 only equal to minus 6 is divisible by minus 30, but there is a less space Gagan side. Here it is the direct minus 30 by 6 only, minus 5. And here not here it is equal to 6 by 36 also. Minus into minus is the plus, so that's why it's a 1 by 5 only. So that's why the both are equal. Is it equal? No, it is also no only. All are not equal only. So that's why you can is not equal. So that's why you can here these all is not satisfy or are not commutative property for under also division only. Are you understood Gagan neatly? For integers. Yeah. This is its over, and next one is the division by 0 only. Yeah, first one we can divide anything into 2 parts, 3 parts and but not 0 parts only. The any integer is divided by 0 is a meaningless only, but there is any integer. So for example of a by 0. A by 0 means is that meaningless only, not defined. 0 is divided by anything, for example of 2, so that is the 0 only. But here 9 by 0 means is that not defined. Okay na, not defined. And 8 by 0 is not defined. Okay na, meaningless only. And 0 is divided by the 0 is divided by non-zero integer are equal to 0 only. Okay, any integer is divided by 0 is meaningless, and 0 is divided by the any 0 integer is equal to 0 only. Are you understood Gagan side? And first one is 0 by is anything is the 0 only. Okay na, anything by 0 is the not defined. For any integer a divisible by 0 is not defined. Is not defined. Yeah, but yeah 0, but 0 is divisible by a equal to 0 for a not equal to 0. Okay na? Okay, now you understood 0 by a and something equal to 0, but a is not equal to 0. Okay, something is there, that is a 0 answer. Yeah, next one is the division by 1 only. Yeah, division by 1 is the some following the some examples. Observing that here is the some examples. Yeah, let us take that 1 and 2 and 3 and 4 examples are taken. Today we will learn it in the, this one only. Division by 1 only. Yeah, first one only. Solutions. First one is the minus 6 is divisible by 1. Minus 6 is divisible by 1 means is the minus 6 only. And minus 6 by 1. So that's why the minus 6 only. Okay. Are you okay? Very easily. And minus 12 is divisible by 1 is the minus 12. And minus 24 is divisible by 1 is the minus 24. 10 divisible by 1 equal to 10 only. Are you okay, Gagan sir, neatly? What are you can observing from the above examples? What are you can observing? What are you observing there above examples is the negative integers or positive integers is divisible by the 1. It gives the same answer only. Okay na? Same integers as the quotient is the same only. And this is the minus 6 and here it is also minus 6 and minus 12 only. Okay na? And same integers is the quotient is the same only. So you write it here. It is the answer neatly. Negative integer from above examples. Negative or positive integer divided by 1. Yeah, we will get this we will get the same integer. We will get the same integer of quotient is the same only. So that's why I can here it is divided by gives the same integer. Same integer as quotient. Are you understood, Gagan sir? Are you understood from the above examples? Or you understood, Gagan sir? Negative integers or positive integers. Here it is also positive integers. So both are is divisible by 1. We will get the same integer as same quotient is the same only. Same integer as quotient is the same. In general, for any integer, a divisible by 1 equal to a. Okay na? Yeah. Next one is the other examples. When we divide any integers by minus 1. If you take the some examples only, 4 examples only. If you take the minus 1 only, if you say we take the integers only. So that's why if you say alag examples only, minus 6 is divisible by minus 1. Minus into minus 1 is the cancel. So that's why is the we will get the same answer. We will get the same integer for quotient. No, here it is that minus 6. Here it is the not same answer only. We will get that not same answer. So that's why is the here it is also all are the minus is both are integers. Both integers is divisible by both integers is the minus only, negative integers. So that's why is the negative integers minus is cancelled. So that's why is that 12 only. And here it is also all are the negative integers 2. All are the minus cancelled. So that's why the divisible 24 divisible by 1 is that 24 only. Positive integers. So here it is also 10 is divisible by the minus 1. What is 10 only. So above examples, what are you understanding Gagan side? What are you observing here it is? Here it is if any integers is divisible by the minus 1, we will get that not a same integer as the quotient only. Okay, now it is the minus 6, here it is the plus only. So it is not same integers, it gives its additive identity. Additive identity means is the minus 6. Minus 6 is divisible by 0. Alag minus 6 by 0 is not defined. Alag examples additive, it gives its additive identity only. If it gives the additive identity only. If it's an additive identity minus 6 then adding of 0. Adding of 0 we will get the same answer only. But you are under division, but you are not same answer. We will get that not the same answer only. If it's addition, if it's okay. Additive identity, if it's okay.